All right, dear children, welcome back to the class. Today we'll have a discussion on electricity. Okay, class 10 electricity MCQs. All right. So as I told you in Kalparuksha classes, we follow step-by-step process. You know about that. We follow that step-by-step process we follow to solve all the questions. And once again, I welcome you to the class and I start with these questions. Okay, let us try to solve them. What is the first question? Look at this. Which of the given is the SI unit of electric current? Electric current, what is SI unit? Ampere, right? Ampere is the SI unit of electric current. And current is equal to Q by T, right? So Q by T means it is Coulomb per second only, and Coulomb per second, or it is also known as ampere. Coulomb per second or ampere. So here is the answer. So this is the first answer. I hope it is clear. Now the hindrance presented by material of conductor to the smooth passing of electric current is known as, this is resistance, no? Hindrance to the passage of electric current, that is resistance only. This is also clear. Next, a fuse wire is inserted in which wire? Live wire, in the neutral wire, in the earth wire, may be connected in any line. No, it is in live wire, no? So two wires come here, no? So one is live wire, one is red in color, another is black in color. Whichever is there in black in color, that is called as neutral wire. This with this red wire only, the fuse will be connected. So always it is connected with a live wire. I hope it is also clear. Third thing is also clear. The fuse is in live wire. The rate of flow of electric charge is known as, definitely electric current, no, because current is equal to the formula is Q by T. Rate of flow of charge Q by T only. So that's why it becomes electric current. All right, dear children. So the four questions are clear, I guess. Okay.
Yes.
Yeah. So let's move to next question now. Fifth question. Let us have a look at this question. The instrument used for measuring the electric current. Electric current is measured by ammeter, no? So instrument is ammeter. So this is also clear. Let me move forward with the sixth question. Look at this question. What is this question? The amount of work done in joules when one unit electric charge moves from one point to another point in an electric circuit is called electric current, electric resistance, electric conductance, potential difference. Potential difference is the right answer because we know that here is one point A and here is another point B, and it is having the potential VA, and here is the potential VB, and it moves from A to B, and here the work done is WAB. So this work done from A to B per unit charge. Per unit charge, that means per coulomb it is. Whatever it is there, that is only known as potential difference between this point and this point. No, potential difference, potential of point B minus potential of point A. So VB minus VA. So that's why it becomes potential difference. Is it clear? Sixth question.
Yes, sir.
Yeah. So that is a potential difference. Let's go to seventh question. The unit of potential difference is volt. Yes or no? Actually, potential difference means it is W divided by Q. This W by Q means joule per coulomb. This joule per coulomb itself is known as volt. Volt and joule per coulomb both are same. So that's the answer is volt. The relation between potential difference V and current I is, V is proportional to I square. It is I square, okay? And next is V is proportional to 1 by I. V square is proportional to I and V is proportional to I. So this is the correct option, no? So we know that Ohm's law, potential difference is directly proportional to current, and V equal to Ri, and it becomes V equal to IR, and things carry forward. So that's why D option is correct. Now the relation between potential difference and current was discovered by Ohm, no? Ohm's law it is. So that's why Ohm is the right answer for this. 10th one, the obstruction offered by material of conductor to passage of electric current is known as resistance only, no? Same. Obstruction means resistance only, or hindrance, obstruction, hindrance, resistance, both are same. Okay. So all are same things. So that's why it becomes resistance. Is it clear, dear children?
Yes.
Yes. Okay. Now let's move on to 11th question. Let's look into 11th question. The SI unit of resistance is ohm. Resistance is ohm. We know that. Now look at this 12th question. Which of the given statement is not true regarding the electric setup of the verification of Ohm's law? Which is not true, they are saying. The voltmeter is connected in parallel with the known resistance. It is true. Voltmeter has to be connected in parallel only. Everybody knows that voltmeter is connected in parallel and ammeter is connected in series. All right. Now, second, it is true. You should not take this because they are asking which is not true. They are saying The ammeter is connected in series circuit. Correct. It is also correct. The rheostat can only increase the resistance in electric circuit. Okay, let's look into this. Now, single key is used to switch on or switch off the electric circuit. Yes, I mean, this is also true. Rheostat can only increase the resistance in electric circuit. No, rheostat can be used to increase as well as decrease. Rheostat means variable resistance. What do you mean by rheostat, dear children? The meaning of rheostat is variable resistance. Now, variable resistance means this can increase the resistance or it can be used to decrease the resistance also. So that's why rheostat can be used to increase as well as decrease the resistance in electric circuit. That's why it is not true. Therefore, option C is correct answer for this. This is not true. That's why it is correct. Clear? Is it clear or not?
Yes.
Yeah, so I hope it is clear. Now let us look into 13th question. Look at this 13th question. So what is this question? A voltmeter is used to find potential difference in any electric circuit. Which of the statement given below is true? True statement they are asking. Voltmeter is high resistance instrument and connected in series. No, in series it is not connected. So that is wrong. They are asking about true statement. A voltmeter is a low resistance. No, voltmeter is high resistance. Low resistance is not there. That's why wrong. Voltmeter is a high resistance instrument and it is connected in parallel circuit. Yes, this is correct. A voltmeter is a low resistance instrument and connected in series circuit. No, this is also wrong. So that's why option C is correct. I hope it is clear. Voltmeter means it should have high resistance. High resistance it should have and it should be connected in parallel. Ammeter means it should have low resistance and it should be connected in series. So now they're talking about voltmeter means it should have high resistance and it should be connected in parallel. I hope it is clear and answer C is correct for this. Clear, dear children?
Yes, sir.
Yeah. So based upon this voltmeter connection and ammeter connection, questions can be framed. Now look at this 14th question. A battery of 12 volt is connected in series with resistors 0.2 ohm, 0.3 ohm and 0.4 ohm, 0.5 ohm and 12 ohm. How much current would flow through 0.3 ohm? They're asking. How many resistors are there? There are so many. 0.3, 0.2, 0.3 means 0.5. 0.5 plus 0.4 means 0.9. 0.9 plus 0.5 means 1.4. 1.4 plus 12 is 12.4. So resistance is 12.4. Resistance is equal to 12.4 I got. And voltage is like 12 volt. They're asking how much current. Current is equal to, what is the formula? V by R. What is the value of V? 12. 12 divided by 12.4. 12 divided by 12.4 means definitely it, it won't be 0.5 because 12 by 24 means it will come as 0.5. And 1.11 definitely this won't come. Now it may be 12 divided by 12.4 means 0.895 may come, no? Because they are like almost the same. 12 by 12 means it becomes 1. Now 0.4 is there. If you want to do the calculation, no need to do the calculation here. But still, if you want, you can do it. So 12 divided by 124 divided by 10. So it becomes 120 divided by 124. So if you do this, so definitely we are going to get this answer 0.895 ampere. So that's why this becomes the correct option. No? Yes or no? You have to guess. There is no need of full calculation here. Okay, with guessing, you have to take this. Clear, dear children? 14th question is clear? Yes or no?
Yes, sir.
Tell me. Yeah, I hope 14th question is clear. Try to guess it. Now 15th question, look at this 15th question. On which of the given resistance does not depend on? Resistance equal to, what is the formula? Rho L divided by A is there, no? It depends upon length, yes. It depends upon cross section area, yes. It depends upon temperature also, yes. It depends, because we say in Ohm's law at constant temperature, no? Why? Because if a temperature is not constant means resistance will change. Density, I mean, on all these things it depends, but it does not depend on density. That means these are all wrong answer, because on this it depends. They're asking on which it do not depend. That's why it do not depend upon density. That's why option D is correct. Understood? So resistance depends upon length, area, and what? Temperature. So it depends upon length, area, and temperature, but it do not depend upon density. All right? Understood? I hope it is clear. Yes? Tell me.
Yes, sir.
Okay. Fine. So this 15 question is also clear. Let me get on to 16 question. In parallel combination of electrical appliances, total electric power increases, decreases, does not change, remains same. What is the answer for this? Tell me. In parallel combination electric power, what happens to electric power? For example, I have one device here. This is having resistance R and it is connected to voltage V. I have got one more resistance. Let me call this as resistance R1 and this one as resistance R2 and it is connected to one battery here. Now, if both of them are connected to parallel, if both of them are connected in a parallel like this, and it is connected to one battery like this is like plus or minus V, and it is R1 and it is R2. Now look at this. Here also power is V square by R1, no? Because voltage is V here, and here the power is V square by R2. Now, if you connect both of them in parallel, here also power will become V square divided by R1. Here also it becomes V square by R2, no? Here also power is same, here also power is same. If you connect them in parallel, there is no change in power, no? That's why power do not change or not. Are you getting my point, what I'm trying to say? Yes or no? See, I mean, if you're connecting them in the parallel, that means will the voltage change? Voltage is not changing, no? I mean, here also it is getting voltage V, here also it is getting voltage V, means power won't be changing. If you connect this in directly to the circuit, here also if you connect directly to the circuit, whatever this will be having power, single also it will be having the same power. This also will be having the same power. That's why power do not change. Clear?
Yes. Yes, sir.
I hope, Deepti, is it clear, Deepti? Okay, fine. I hope this question has to be clear. Let's move on to 17th question. How the charge will flow? By heating them, by applying potential difference, both, none of the above. Both is the right answer for this, because charge will be flowing by applying potential difference anyhow that is there. For example, high potential, low potential is there means the charge will move in a particular direction. Okay, the charge will be moving from one potential difference to another potential difference that is there. But by heating also, for example, this is the nucleus. Inside nucleus, proton and neutron are there, and around this, what are there? Electrons are there. Now, if you increase the heat, if you heat it, these electrons will jump or not. If these electrons are jumping outside, means what is happening? If these electrons are jumping, means by heating them, electrons can flow or not. That's why both is the correct option. Understood? For 17th question,
Yes,
option
sir.
C is correct. So option C is correct for that. Let me get into 18th question. If length of a conductor and its radius is increased twice, how the resistance will change? Okay, there are so many options given. Length of the conductor is doubled means, look at this, initially resistance is like rho L by A, initial resistance. Now length of the conductor is doubled means, now R dash is equal to what I will say, length of the conductor and its radius are increased twice. That means length is twice means it becomes R into 2L. And divided by area means this is like pi r square, no? Rho L divided by pi r square. Now what happened to this radius? Radius is increased twice. That means pi into, instead of this r, what they are writing? They are writing 2r whole square. That means radius is doubled. So here only area pi r square is there. Here it becomes pi into 2r whole square. Then r dash is equal to, it becomes rho into 2l divided by pi 4r square. That means 2 ones are 2 twos are. So that r dash equal to, it becomes what? Tell me. Rho L divided by 2 pi r square. Rho L divided by 2 pi r square means 1 by 2 into rho L divided by pi r square. Look at this. Initially rho L divided by pi r square means the resistance was r. Now new resistance I am getting 1 by 2 into r. That is like resistance became half, no? Rho L by pi r square means r only, no? So 1 by 2 into r. So resistance will remain unchanged? No. Resistance will increase twice? No. Resistance will become half? Yes. This is the right option, no? Everybody got this? Just look into this calculation and try to get it right. R dash equal to rho into length is doubled means 2L and radius is doubled means 2R whole square. 2R whole square means 4R square it becomes, then calculation is carried forward. So that's why resistance will become half. Is it clear? Yes? Tell me. Clear or not?
Yes, sir.
Yes, sir.
Yeah. All right. So let me get into this thing now. I think Nisarga, did you join the session, Nisarga?
Yes, sir.
Nisarga joined. Okay, fine. All right, fine. Now let's get into this question now, 19th question. The potential difference applied is directly proportional to current only if, always, never, sometimes, when temperature is constant. Yes, temperature is constant because we say potential difference is directly proportional to current at constant temperature, we say, no? So that's why V is directly proportional to I at constant temperature. So option D, when the temperature is constant. This is the right option. Got it?
Yes, sir.
Okay. So this was the 19th question. Now let me move on to 20th question. Now do this question, 20th question. Equipment resistance of 4 ohm resistance in parallel. Now this question is it's not clear, so that's why better to avoid this. Look at this equipment resistance of 44 or 4.4. What is this? We are not understanding, so ignore this question. 20th. Now 21st question, which of the given conditions represent more resistance at constant temperature? The red line, yellow line, both are equal, can't be said. This is also some other series question, you can neglect this because we don't have I mean in our syllabus, all these things are not in our syllabus, so that's why you can neglect this also. Now come to this. There is a wire of length and cross section area A, which of the given have least resistance? Least resistance they are asking, okay? Length doubled, area halved, length tripled, area doubled, length halved and area doubled, the original wire. Which one will be having least resistance? They are asking, less resistance. There was a wire of length L and cross sectional area A. That means its resistance is like R is equal to rho L by A, no? Original resistance is like rho L divided by A. Everybody knows it. Now after that, what is happening? Length is doubled and area is halved. That means whatever resistance come, let me call it as R dash, that R dash become rho into, length is doubled means it becomes 2L, and area is halved means it becomes A by 2, and 2 comes above and it becomes a 4 rho L divided by A. Yes or no? 2 comes above, it becomes 4 rho L by A. That means it is having maximum resistance. That is like 4 times of the initial resistance. That means this cannot have least resistance. That's why this is gone. Now length is tripled, area is doubled. Now length is tripled means rho into length is tripled means 3L divided by area is doubled. Area is doubled means 2A. Area is doubled is 2A means 3 by 2 means what it comes? It comes to be 1.5, no? 1 point rho L divided by A. 1.5 rho L by A means again it is having more resistance. It is not, I mean, this is only having less resistance than this. So that's why this is also gone. Now length halved and area doubled. Look at this. Now this R dash, no. So how to calculate R dash is equal to rho. Length is halved means it becomes rho L divided by A, rho L divided by 2. Yes, so rho L means L by 2 here. Length is halved and area is doubled. Area is doubled means 2A. Rho into L means L by 2 here because length is halved, and area doubled means it is 2A. So that means whatever R dash I get, that becomes rho L divided by 4A, no? So that becomes 1 by 4 times of R, no? So that means rho L by A is R. That's why 1 by 4 times of R means it has become almost 1/4. That means this is having least resistance, no? That's why C is the right option. Everybody got this question, 22nd question? Have a look into that, dear children. Yes? Are you getting my point? So this is having least resistance. Yes, I hope everybody got it. So based upon this R equal to rho L by A, questions can be framed. So that's why you should be solving those questions. Right, dear children? Is it clear? Okay. I hope this is clear. If any doubt is there, please let me know. Is it clear? 22nd question. Yes. Okay, fine. So let me move to 23rd question. On which of the given parameters specific resistance is nothing but resistivity. The meaning of specific resistance is resistivity. Okay. On which of the given parameters specific resistance depends? Does it depend upon length? No. Does it depend upon area? No. Does it depend on current passing through it? No. It only depends on temperature. Based upon, listen to me, this whatever resistance is there, it depends upon length, area and temperature. But this resistivity depends on only two things. Those two things are, one is nature of material. One is the nature of a material. What kind of material is there? and next one is temperature. So that's why the specific resistance means resistivity and depends upon temperature. Very important question, and you can take this option. All right, dear children, I hope it is clear to you. So which question we are at? I'm sorry. I think we're at this question. Okay. So the option is temperature for this. Clear?
Yes.
Tell me. Yeah. So now let me move to next question. Let me see this question. A resistor of length L is connected to a battery and current I is given through it. Okay, fine. If it is divided into 3 parts by length, okay, 3 parts it is converted, and all having the same cross sectional area, okay, cross sectional area same, are connected in series with the same battery. The current flowing through them will be, what is the current flowing through them? A resistor of length, that means there is a conductor like this. I mean, resistor means it is having length L, is length L is connected to a battery and a current I is given. Okay, fine, no problem. Current I is given, current I is passing through that. Now what they have done, they have cut this into 3 pieces and they are connected in series, one after the other. Now if these are connected in series, mean the resistance will change or it will remain same? It will remain same, no dear children? Look at this, this resistance is R by 3, this resistance is R by 3, now this resistance is R by 3. R by 3 plus R by 3 plus R by 3 means 3R by 3, 3 get cancelled, and it is same as that of resistance R only. Whatever resistance was there above, no, it is same as that of this end. Then it is connected to this battery here. Now whatever current comes here, whatever current flows, it will be same current, no? So what will be the current in this? Same current I will be there, no? Tell me. Tell me, dear children, same current I will be there or not? Yes or no? So because these are same resistances only, okay? If they are connected in parallel, then it should have been something else. But they are connected in series, so that's why the same thing happens. I hope it is clear. So answer is I. Okay. So let me go forward. 25th question. Do this question. Two resistances R1 and R2 are connected with a cell in parallel. Find the ratio of current flowing through R1 to the current flowing through R2. Okay, do this. They are connected in parallel, no? With a cell, they are connected in parallel, R1 and R2. Correct? R1 and R2, they are connected in parallel with a cell or with a battery. So this battery is like plus or minus V. Here also I'll get V, here also I'll get V. So what is the current through R1? That is I1. I1 is equal to V by R1. And what will be the current through R2? That is I2 is equal to V by R2. Now they're asking find the ratio of current flowing through R1 to the current flowing through R2. So that is like I have to find out I1 divided by I2. So I1 means what? V by R1, and divided by I2 means what? V by R2. So it becomes V by R1 into R2 by V. V get cancelled, and what remains here? R2 divided by R1 remains. So this is the option, R2 divided by R1. I hope everybody got it. 25th question. Yes, because current V by R1, because here voltage will be same in parallel connection, no? That's why current I1 is V by R1, here also V by R2. And when we divide them I1 by R2, we get V by R1 divided by V by R2, and we cancel them and we get it as R2 by R1. Okay, fine. Just look into that. Now, which of the given statement is true regarding ammeter and voltmeter? Already I have explained this. Ammeter is connected in series, true, with the required device, voltmeter in parallel. Yes, it is true. It is true. Both ammeter and voltmeter are connected in series. No. The voltmeter is connected in series. No. They can be connected in any way. No. This is the right option. 26 is the right option. Already I have explained this question, and question can come on this. I hope it is clear, dear children. Yes? Okay. So let me move forward to next question, 27. Let us do this. Amount of energy delivered by a power of 1 kilowatt 1 hour is called. See here, amount of energy released by a power of 1 kilowatt in 1 hour. Energy means we know the formula, no? Energy is equal to PT. P is like 1 kilowatt and time is 1 hour. So 1 kilowatt hour. So watt hour. So kilowatt hour. So here is the option. Power is like how much? 1 kilowatt. And how much time? 1 kilowatt into time is 1 hour. So it becomes 1 kilowatt hour. So option is 1 kilowatt hour. Already in the class also I have told you that power, whatever energy is there, no, that energy is equal to PT. If this power is in watt and T is in time, second, it becomes watt second. It is in a kilowatt and it is in hour, means it becomes kilowatt hour. So like that, according to the situation, it will be changing. All right. So this is the energy. Now let me go to 28th question. In SI unit, joule per coulomb is equal to, joule per coulomb means what? Joule per coulomb means work done per unit charge, no? Work per unit charge means voltage, no? Yes or no? So voltage means volt only. So this is the right option. So already I have discussed this also. When I was discussing about the unit of potential difference, I discussed this. Okay, volt is the right option. Everybody got this?
Yes.
Clear or not? Yes. Okay. So 28th question is also clear. Let us look at this. The materials having non-linear voltage current relationship are, they are called non-ohmic device. Dear children, ohmic device means which follow Ohm's law. Ohmic device means which follows Ohm's law. They are called ohmic device. That means the graph between V and I, how it comes to be a straight line. If V increases, V is directly proportional to I, no? So if V increases, I will also increase like this. Okay. Non-ohmic means how they will be, no? This is the voltage and this is the current. Non-ohmic means it will be like this. Look at this. Now voltage is increasing at the initial stage, but current is not increasing. Afterwards, suddenly, with small increase of voltage, the current has increased suddenly. But here it is not like that. Here steadily it is going. Steadily it is increasing along with voltage. All right. So that's why materials having non-linear, this is called as non-linear relationship. And this one is known as linear relationship. This is called linear and this is non-linear. So that's why such devices are called non-ohmic devices. I hope it is also clear. Yes, is it okay? I mean, that linear relation means the graph should be straight line. Non-linear means the graph should be like this. So such devices are non-ohmic device. Okay. And these devices are called ohmic device. Okay. Fine. So let us look at this 30th question. Due to flow of positive or negative charges or both charges at the same time, electric current is produced, light is produced, heat is produced, air is produced. What is the right answer for this? Due to flow of positive or negative charge. Yes or no? I mean, any charge is flowing means what is produced? Electric current is produced or not? So due to flow of positive or negative charges or both charges at the same time, electric current is produced. This is the correct option. So electric current is produced. Correct? Flow of charge means whenever there is a flow of charge, irrespective of positive charge or negative charge, there is nothing called positive charge actually. Flow of charge means what will come? Current will come. I hope it is also clear. All right, dear children. Did you understand all these questions? 30 questions, whatever I have brought them for you. Did you understand all of this?
Yes, sir.
Yes, the main things what you have to concentrate in this chapter is, one is V equal to IR. Based upon this, they may ask you current, voltage and all. You have to concentrate on ammeter and voltmeter, how they are connected. Then you have to concentrate on this potential difference equal to W by Q, all units and all. Then you have to concentrate on power is equal to VI, then power equal to I square R, then power is equal to V square by R. Okay, these things. Then resistance in series, Rs is equal to R1 plus R2 plus R3, and 1 by Rp is equal to 1 by R1 plus 1 by R2 plus 1 by R3. So all those things, what are there in the, this combination. Then electrical energy is equal to PT. PT means unit will be watt second. Commercial unit is kilowatt hour. So like that, all these things you have to concentrate in this chapter so that you get full marks. Is that clear, dear children?
Yes, sir.
So you concentrate on them, and there are some other questions also. I'll be sending them to the group. You can solve them after this 30th. Also, there are some questions. Try them. Whatever doubts you have, you can ask me. So there is no end. Answers also are there at the end. You can have a look there. Okay, so these answers are okay. No, don't have a look at the answers directly. First of all, solve them. Okay, try to get a feel of these questions. These are similar questions. These are all similar questions. After 30th question, whatever they have come, no, they are all similar questions. You can solve them and you can get rid of this chapter. All right, dear children, and you can perfect this chapter.
Yes, sir.
So I'll be sending that. Okay, fine. I hope the session was useful to you. And tomorrow I'll be discussing about magnetic effects of electric current and sources of energy also. Both the chapters I'll be discussing tomorrow. Then physics part will be over, so that we can come back to mathematics part, that is surface areas and volume and construction. Is that clear?
Yes, sir.
So you guys keep on preparing for the keep on preparing for this 17th. We have test, mathematics 40 marks test will be there based upon all the chapters. You prepare for that. Until then, you have to keep on reading and keep on solving. So you can watch the recorded videos also. They are also available. You can go to the playlist of YouTube channel, official YouTube channel, and you can watch those videos. Clear, dear children?
Yes, sir.
Okay. So till then, take care. Have a good day. Bye bye.
Bye, sir.
Bye everyone. Bye. Bye everyone.